Cansen, welcome back again.
Hello, thank you.
Today we are going to talk about how to execute a multi-class text classification.
Yes.
To execute these tasks, we need to first analyze the data and pre-process the data as usual in deep learning.
Yes.
So today, Cansen will talk about in two parts. In the first part, she will talk about analyzing the data and then pre-processing it with Keras Text Vectorization pre-processing layer. After that, in part B, Cansen will present transformer-based approach to classify these data in multi-class classification scope. In multi-class classification, we are going to use the GPT-3 model as a model, but not a pre-trained version of it. We are just going to use one or two blocks of GPT-3. And then maybe Cansen will talk about how to use the pre-trained transformer model, for example, Bert. Am I right, Cansen?
Yes, you're right.
Okay.
And later I will show the Bert also.
Bert. Okay. So, for the audience, most of you know that we are sharing our research meeting on YouTube channel, Murat Karakaya Academy, along with many tutorials in deep learning, machine learning. If you like this kind of content, please subscribe to Murat Karakaya Academy YouTube channel so you can be notified when new uploads arrive. So Cansen, we are with you, we are listening to you. So while you are presenting your topic, I will ask several questions just to clarify the material that you are presenting as a student sometimes, sometimes as a non-expert, sometimes as an expert. So please keep in mind that my questions are just to give you some opportunity to explain more, okay? And for the audience, if you have any questions, any comments, please write to the comment section under the video description. So we are gonna reply you as much as we can. All right. So the ground is yours, Cansen. Please start.
Thank you, Hocam. Today I'm going to talk about multi-class text classification, and Murat Hoca said that first we are going to examine this subject in the two parts. The first part, it's going to be a data analysis and pre-processing to training data. So, but before that, I want to give a brief explanation of text classification and multi-class text classification. Text classification, also known as text tagging or text categorization, is the process of categorizing the text into organized groups. So there are some common examples in this natural language processing area, like sentiment analysis, topic detection, and language detection. So in sentiment analysis, it's a process of understanding if a given text is talking positively or negatively. You can see many examples about this, most of them with the IMDb movie data set. And the topic detection, and this is our subject also, the task of identifying the theme or topic or category of a piece of text. And there's a language detection, the procedure of detecting language of the given set. So in a basic way, it goes like this. We have some documents, some text, and also for each text, we have categories, also known as labels. And we are training this training data with some machine learning algorithms. And then we are going to try to categorize the new documents, new text data with using this model, and try to identify which category this data belongs to.
Okay, so basically we have the training data with labels.
Yes.
And we have the test data, of course, with labels, but we are not going to use these labels in the testing. We are going to train a model. It could be a machine learning model, or it could be a deep learning model. And then we try to test on the test data and see the performance of the success of categorization or finding the correct label for the given text. So this text can be a document, like 2-3 pages of Word document, for example, or it could be just a tweet, short text, very short text. It could be a review, still a short text, or it could be a book, very long text to categorize, right?
Yes, you're right.
Okay, thank you. Please continue.
And multi-class text classification, so it means that, as you know, that you have a video about this actually. It's not a binary class text classification, it's multi-class. So it means that we have more than 2 classes, and an input can belong to only one class because it's not a multi-label. For example, topic classifier. If there are more than 2 topics or categorized, the new data, it's going to belong to one category, one topic. So it can be about technology, it can be about sports, or it can be about fashion. So this is
not at the same time too often, right?
Yes.
One often. Okay. So basically classification is a very common task in machine learning. So there are the kinds of classifications. The one you mentioned is binary classification, if there are only 2 classes. And there are the multi-class if there are more than 2 classes, but we can classify the given item only with one label. And there are the multi-label text or multi-label classification. In that case, there are multiple classes still, but for the given item, we could label it with multi-topics, multi-labels, multi-class. So for the audience, if you are interested in how to do this kind of classifications, we have a separate tutorial series, how to do classification in deep learning with Keras and TensorFlow. I will leave the link into the video descriptions so anybody can access the code, the blog, and of course, the videos in English and Turkish. Okay, let's continue.
So let's look at our dataset. Our dataset name is multi-class classification dataset for Turkish. So it contains 430K lines and 32 categories. So each category roughly has 13K commands. So data is collected from Turkish websites, and data is basically contains the reviews of some products and product categories. So users writing some reviews for some products, and each product has a category. So I'm going to explain the data set and the data analysis also.
So if you go back, so the source is on the slide at the bottom. So it's collected by Savage Y. So it is on the Kaggle. So anybody can access and use it. Also, we are gonna share what you are gonna see in a moment, the code in the video descriptions. We are gonna put this code into the GitHub, and I will share with the link in the GitHub. And you can easily access this data set. And by the way, the reviews not only about products, but the reviews about the services as well, right?
Yes.
So the services and products. All right.
Okay, let's continue with the data analysis.
Okay, so as I mentioned in 2 minutes ago, so we are gonna share this Colab notebook as well in the video descriptions.
Okay, so these are our libraries. And you have already explained this part, I think, download the Kaggle dataset into the Google Colab.
Yes.
So I got help
from you. Video how to download a a Kaggle dataset to the Google Colab with ease. So I will leave a link to this tutorial as well. Okay.
Yes, and I got help from your works, and I download the Kaggle dataset, multi-class classification data for Turkish, to my drive, and then I can use it in the Google Colab. So let's start with exploring the dataset.
Okay, for the moment, I would like to clarify that after downloading the dataset from the Kaggle website, then you unzip it, then you have the Ticaret Yorum CSV file in that zip file. We are gonna use that file as the dataset, raw dataset. Yes, continue.
Yes. So let's look at the data info. We have two columns in this data sets, category and text. Category is the 32 category, as I mentioned before. There are some categories about the products and services, and there are some reviews. These are the text.
Okay, let's clarify another thing. So when we mention about category, we mention or we synonymally use that label and topic. So for us in this tutorial, in that context, category, topic, and label are the same.
Yes.
Or class are the same.
Yes. And let's look at the data head. As you can see, our first category is shopping, in alışveriş in Turkish. And also there's a reviews as a text. As you can see, we have two columns, category and text. And these are the reviews. And these are the category that reviews is belong to. So let's look at the describe of the data. So we have text in 431,306, and we have 32 category in here. But as you can see, there is a difference in here, count and unique. So it means that we have 4,075 non-unique comments. So it means that we have some duplicate values. So we are going to handle this duplications. And also we have a example review in here and the category. So because of that, we should remove the duplications first of all. So to do this, we use drop duplicates in here. And again, we can check the describe. We are going to see the count and unique is the same number. So it means that all reviews are unique right now. So let's look at the data analysis. First of all, I want to show you the number of reviews for each category. So we have 32 categories, as you can see. And Murat Hoca has mentioned that we have some products like electronic, but also we have some services like tourism and education, like that. And if you check the value counts, you're going to see that number of reviews for each category is similar. But also we can check it from this plot. So we have 32 categories, and as you can see, our data is balanced.
Almost balanced, huh? Not exactly same, but almost balanced.
Yes. So that's why we don't have to make any process to getting a balanced data, because it's almost balanced.
And
so
by the way, you might remember that we have already discussed how to measure the success of multi-class classification when there is imbalanced data set. So when the data has some different number for each class samples, then it's called imbalanced data set. In the imbalanced data set, it's not easy to measure the success of the multi-class classifier. So we have a tutorial series on that, how to handle imbalanced data in multi-class classification, but it is in Turkish. Still, I will share this link in the video descriptions. Maybe someone would find it useful for himself.
Yes, thank you. And we can check the number of words for each review. So to do that, we are going to add a words column to our data set. And as you can see, we have category text and words for the each review.
Actually, it is number of words, right?
Yes, number of words. For example, in this review, we have 50 words. In this review, we have 40 words. It's like that. So we can check the these columns describe. We can count of the words because these are the numbers. We can check the mean. So as you can see, the mean is
Cansen,
44. Yes.
can I correct something? This count is not number of the words. This is the number of rows of the words. So it will be equal to the number of samples in the data set. Okay, it's not the number count of the numbers, or it's not the count of words. It's the count of word rows as the text and as the topic category. So it's the same. Pay attention that it's exactly the same number for the rows in the data set. Okay. So let's correct this. It is not the number of unique words in the data set. It's not. It's just the raw number. Okay.
Okay. And I try to look at the distribution of words for each review. And I saw something like this. It means that the most of the reviews has 50 words.
So in that histogram, we can understand that very, very low numbers reviews are larger than 60 words and less than 20 words, right?
Yes.
So most of them actually is between 40 and 50, I believe.
Yes, that's correct.
But can you go a little bit up for the, yes, in that cell. So mean is here, these are the descriptive statistics, right? We are calling these kind of statistics descriptive statistics. In the descriptive statistics, we see that it is the mean is 44. But if we check the quarters, so the 51, the third quarter, right? 46. So what you can say about when you need to put a limit on the shortest and the longest reviews?
I think I didn't do it, but we should do it. I think we can remove the, for example, if it is the words less than 46, we can remove it, I think.
But I think I will not remove the half of the data. If you are removing it, you see that in the half of the quarter to the second quarter. So you can, if you remove it, you will lose half of them.
Yes, I don't know how can we decide.
Okay, look at the minimum. Do you think that 2-word review will make any sense?
No, but 10 maybe makes sense.
Maybe, but if you are looking and deciding this, I will not select 40 to 50, but I would select, for example, 20 or 40. If you go to the histogram, for example, in that histogram, I am sure that if I select less than 25, I will lose not too many samples. Yes. Am I right? You can see the numbers on the Y column. So it is only 50,000 or so out of 400K samples. Yes. So by looking this, and for the longer ones, we are gonna see that in the pre-processing layer, we are gonna put a limit on the longer one when we create the tokens, when we tokenize it. But in the pre-processing, actually, for the training data, you need to limit the minimum size samples here at this time. Otherwise, you will get these very less informative, because the number of the words is less than we imagine that it is information, what they carry as information is very less. So you cannot train your data. And in the test, actually, you cannot use it as a test point because it is very less very, very less information inside. So it would be very wise. It would be very wise if you look at your histogram data and check several examples. For example, you can put a query here saying that show me the reviews which has words, number of words less than 15, for example. And you can see that if you, as a human being, if you can decide the topic by looking at these 15 words or less than 15 words, if it still makes sense, you can use it. If it doesn't make sense, then you can understand that 15 words is not enough for training and testing. So you can remove these kind of samples from the data at the beginning. Okay, it's not pre-processing actually. So you are just trashing it. All right. Otherwise, you are gonna always see that maybe your test points, test accuracy will be always low due to this kind of mistakes, due to this kind of nature of data. Okay, be careful.
Okay, and I understand. I think we are lucky for this data set because most of them in here, but if it is not, I think we should check more as you explained.
And here we have the luxury that because the total data set is huge, 400K, it's huge. So we can be a little bit in luxury to remove whatever we don't like.
Yes, okay. And I try to check the longest review and shortest review, but I think I should do this in the category based, right? But I check the longest one and try to shortest one. And as you can see, I think there's some mistake in here. I'm not sure about it because the minimum was the 2 in the describe. But when I try to print the minimum one, it seems like 3 words.
Okay, let me explain this. How we create the word numbers. If you go up, we use the split function. Am I right?
Yes, split function.
If you go up, well, yeah, please click on the split function so everybody can follow it. So this split function is a string class function, and actually it does not tokenize very well. For example, if a punctuation with no space to a word, it considers this dot and the word as a tokenization. So there could be some mistakes, but we are just working on the raw data. Roughly, we are gonna do all the pre-processing after analyzing. So far, actually, we try to do analyze it. So these number of words are actually not tokenized word numbers. Okay, be careful because in a moment we are gonna see that in the pre-processing layer, right? We are gonna remove the punctuations, numbers, etc. So at the end of the pre-processing, we are gonna come up with the exact number of the words in the review. But for the moment, it's very roughly. So you notice that this calculation is not correct when you check by your eyes. Yes. That's a good point. But it gives you an idea about it's not 15, but it could be 46. You understand? So it's roughly.
Yes, I understand. So this was the shortest review. So now we are going to add a category ID because we have a 32 category, but there are also texts and category names. And we are going to turn this category names and hold it as a integer number, integer. So, but before that, let's check the text and category. So this is our text data, text value. As you can see, there are some values. This is our text column. And we have a category column. And as you can see, it starts with the shopping and it's finished with the transportation, ulaşım in Turkish. So we need to add also numbers for each category. So, and before that, we changed the type of the category as a category. But I think we are not going to use this one, right? Because after this point, we are going to only use the category ID. But also, we are going to create a dictionary from the category ID to category name. So, we with using the category codes, and in here, as you can see, we add some category ID column, and now each category has a number. For example, in the tail, transportation has a 31 because the shopping is category ID now 0. It's starting from 0. It continues to the 31 because we have 32 categories.
By the way, the raw data is sorted out according to the category. So the whole reviews are sorted out according to their categories. So they are not mixed. They are sorted out according to the category.
Yes. So now our data set, it's look like this right now: category, text, review, words, and category ID. So, but we need to create a dictionary because we are going to use this number of categories, category ID. But after that, for example, in the test part, when we find the category ID, we also want to see the what is the category name. So that's why we are going to create some dictionaries to use in the future. And as you can see, 0 is alışveriş, is shopping, is 1 is anne bebek, mother and baby. And it goes like in here, 31 is ulaşım. This is ID to category, our dictionary. And also we have a dictionary category to ID. So this is the category name and this is the category ID. And if you want to test it, for example, category to ID dictionary, and what is the alışveriş? It's going to be 0. So ID to category dictionary, if you're checking the 0, it should be alışveriş, is shopping. And also, again, we check the number of categories. If you can calculate the number of categories with using category to ID in here, it should be 32. So let's check the most commonly used words in the reviews. So the 20 most mentioned words in all reviews. First of all, I'm going to show you this. I'm going to use counter, by the way. And as you can see, for the all reviews, not a category based right now, these are the most used 20 words. It starts with the oku. And bir, ve, için, bu, de, da, ama, yok. It goes like this, as you can see. So let's check why is oku the most common word. Because
read, right? Read.
Yes, read in English. Because at the end of each review, we have a devamını oku. It's English, read more. Yes. So that's why the oku is the most common words in the whole data set.
Now, as a student, I have a question for you. Why not devamını? Why only oku is the most frequent one? But what about devamını? They are all together.
Because there is a problem with the devamını, I think. Because devamını, it's sometimes connected to the last word, like this.
So, because so far, as I explained 2 minutes ago, we roughly tokenized by using the split function of the text or string class. So this split function is not a perfect tokenizer. All right. So sometimes dot, dot, dot is in the last one. Can you highlight the last dot, dot, dot? Devamını oku. Here. Yes. No, the last one.
The last one.
Yes.
Here. Yes.
Here, dot, 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 devamını, the split function most probably thinks that dot, dot, devamını is a single token.
Yes, it's
so you cannot see the devamını as frequent as oku, but we are going to handle this. Yes. We are sure in the preprocessing. Now we are just analyzing, understanding data roughly.
Yes. Also, I created a word cloud, and as you can see, devamını oku is really huge in here. So it means we should remove the devamını oku, I mean read more when preparing the training data.
Because it doesn't convey any necessary information for classification.
Yes. And then I try to look the most used words for each category. So as you can see, we have 32 category in here. And these are the most common words for each category and with the count numbers in here. For example, for the shopping, alışveriş, it's bir, and oku ve sipariş, ürün. It goes like this for all of them. They are very similar actually for each category.
In some categories, there are very keywords I see. Yes, for example, hukuk, hizmet sector, the law in the service sector, or in, for example, yes, in watch, the watch keyword. And there are several. For example, Karaca is a trademark for kitchenwares, right?
Also in kamu hizmetleri we have belediyesi.
Yes. So there are several very related ones, but the first 5 or 6 are the words which are very frequent in Turkish. Yes. Like in English, that the a is kind of words are the first 5, 6 words in each category, but maybe you can check more words and you can come up with the keywords in each category. So do you have an idea how can you handle this? We are going to use all the words as equal importance to classify, or we need to think about a little bit more how to create our dictionary after preprocessing.
Yes, I think we should think more. I'm going to remove the oku and devamını oku, but I didn't do anything with the bir, for example. Maybe we
cannot remove bir, but as we know that in preprocessing, we cannot use the whole tokens as the dictionary. We are gonna select it, we are sorted out, for example, as the number of frequency of each token, and then we are just removing less frequent tokens. So this kind of less number of tokens in the data set could be the keywords actually for that topic. If you let preprocessing layer decide which tokens should be eliminated according to the number of appearances in the documents, then you most probably will lose the keywords. For example, a trademark for the kitchenware will be removed, but it's a keyword.
But in topic classification, keywords are really important for us.
So here, when you look at that, the most frequent words actually for each topic do not determine the topic for a human being, right?
Yes.
So it will not help to the machine learning model as well. Yes. So if you try to keep the most frequent words in the dictionary, but remove less frequent words, maybe you are losing some important information about the review and the topic. Because as I said that there could be some service name, some firm names, or some trademarks, and you are removing it because they look like very infrequent in the data, but they are the key actually. So you need to find a way, first of all, not to summarize the tokens as per the frequency, but you need to put the words, for example, the importance of the word, differentiating one review to the others. So the keywords. So one way to do this is to use term frequency inverse document frequency, right? So TF-IDF, so right?
Yes, I'm going to explain TF-IDF also.
Okay, so it's a good discussion for everyone. So you cannot just pre-process the data as somewhere you find a way and you just apply. No, you need to think of your data. So please spend most of your time to understand, to analyze your data, then to process, and keeping in the mind that what you are gonna do with that data, how will affect the model. Okay, so here the frequency is not a so strong measure for selecting the dictionary size and dictionary items. Okay.
Okay. So because of that, you already explained that, I try to check the most important words for each category with using the tf.data vectorizer. But in our model, in our classification, actually, we are not going to use the tf.data tokenization. We are going to use integer for right now. But first of all, just for the analyzing, I just wanted to look at the most important words for each category. But if I'm using the tf.data vectorizer with the whole data set, the collab system down. That's why I took a sample from the data set for each category. So I transformed each review into a vector, and then I use a G2 feature selection on tf.data vector representation. And also, I want to continue from here before that. So we are using a text vectorization because
Keras preprocessing layers. There are many preprocessing layers in Keras. Looks like dense layer or whatever, but they are just layers. So you can add these layers to your model and then export it so that your model can handle raw data, input data. So text vectorization is a preprocessing layer for the Keras, native Keras. So you are going to use this preprocessing, Keras preprocessing layer for text preprocessing, right?
Yes.
Okay.
So why are we using that? Because we need to transform text into something a machine can understand. And you have already explained, there are some ways to do this. So in a short way, transforming text into a meaningful vector or array or numbers. So there are 4 output modes for the text vectorization layer.
But let's stop here. A little bit more explanation why we are using Keras text vectorization layer. You can do this with Python, right?
Yes.
By applying Python string operations. Or you can do this natural language toolkit library, right? There are many ways to handle text preprocessing. But here we are going to use Keras text vectorization preprocessing layer. It is a layer. I want to emphasize that. It looks like a dense layer in the model. So everybody used, I believe, the Keras library to create a dense, to create a deep learning model, for example, dense layer and the LSTM layer, like input layer. So this layer is a, or text vectorization class is a layer. So we can add this layer to the model. And when you save this model to your environment, to your hard disk, then you can load this model again with ease in a different platform. For example, you can save this model in Colab, in the Python environment, in the Colab environment. Then you can upload this model to the JavaScript environment. So when you run this model in the JavaScript on a web page, it will work because your preprocessing logic is implemented in the text vectorization layer. So in the web page, you can get the raw data, for example, text from the user and supply this as an input, a raw input, without doing any text preprocessing. And then the model will handle this raw data automatically because we already implement text vectorization layer as a text processing function. So it's really important that the audience can understand why we choose text vectorization, right? So you can supply the raw data. Otherwise, if you use the Python functions, NLTK functions, then in the JavaScript or when you upload this model, you need to use the same functions to preprocess the input from the user to the model.
Yes.
I think I am clear. Am I? I don't know, Cansen. Am I?
Very clear. Thank you.
Okay. So I strongly suggest everybody to use text vectorization as a preprocessing function.
Yes. So we are going to use an int mode actually in the model. The output's integer indices, one integer index per split string token. But just for the analysis, I want to show you the tf.data, the term frequency, inverse document frequency. So it's different from the integer or count mode because it's going to evaluate how important a word is to a document in a collection of documents. So not only focuses on the frequency of words, so also we are going to understand the importance of words for that category. So then after that, we can then remove the words that are less important for the analysis maybe. So there's a formula for the tf.data actually. So term frequency summarizes how often a given word appears within a document. And inverse document frequency, it downscales words that appear a lot across documents. And then we are going to use both of them. We are going to find the tf.data like this with this formula. So now, let me continue.
Okay, let me provide some explanation. In information retrieval branch research area, this is a main metric. So they have developed. Now we can use this to understand the importance of each word token in each topic. 5 minutes ago, we see that most frequent Turkish words exist in the first 5 or first 10 words for each topic. And we said that it is not informative for a classifier to classify by using the frequency of the tokens. Now we are introducing another metric, which is very popular in information retrieval, to decide the importance of the tokens according to their topics.
Yes. So, as I said before, just for the analysis, I transformed the sample of reviews to tf.data vectorizer and in that kind of vector. And then we are going to use the 3 most correlated terms for each category. So let's look at the results. For example, for the shopping, alışveriş in Turkish, we have most correlated unigrams and bigrams. For example, in the alışveriş, we have seen Migros, Tedarik, and Boyner. So it means really correlated and important. So bigrams means that 2 words. MediaMarkt, şok marketler, tedarik sürecinde. These are all is about the shopping actually. For example, let's look at the mother and baby. The most correlated unigrams are bez, bebek, ebebek.
Baby,
yes.
baby.
Diapers, baby, and e-baby. This is also
trademark.
Yes. And bigrams are civil mağazacılık. This is a
trademark.
Yes, shopping. And again, baby diaper and joker mağaza. This is also shop for the baby clothes, I think. And we have beyaz eşya, as you can see, çamaşır, buzdolabı, arçelik.
Okay, so the audience can read this and just stop some of them. So basically, when we skim this list, we see that the tf.data is very useful metric, right? To decide the importance of the keywords or locate the important words in each topic. But we need to find a way how to select these words or give some more importance when we create our dictionary.
Yes.
Right? But we have Have you done this?
No,
Not yet.
not yet.
Not yet. So my point is here that if you apply preprocessing as the out of the box, it will not always helpful for your classification. Okay. You need to find some way to handle the tokenization before preprocessing. So now we need to, we see in that analysis that we need to find some way to select the correct tokens words to create the dictionary.
Yes.
We cannot count on the frequency of the words and then remove the less frequent words from the corpus. If you do this, maybe here, as you see that the most frequent words will be in the dictionary, but they are useless for the classification.
Yes.
They do not carry any information about the topic.
Yes, there's a huge difference in here, as you can see. For each category, these are the most used words, but these are the most important words for each category, and they seem correct.
So my suggestion for you, we need to find a way to calculate each word in each topic, tf.data value, and then we need to create a preprocessing layer such that for each topic, or maybe we can combine for the whole corpus, we need to remove the tokens that has less value in tf.data, not according to the frequency. But I don't know how can we do by modifying the Keras Text Vectorization layer. Actually, I don't know either.
Yes. Okay, I'm searching for it. Thank you for suggestion.
If from the audience, if somebody has a brilliant solution that we can modify the text vectorization by using the tf.data, but we are not asking that, we don't want to create tf.data vectorization. We don't asking that. We are not asking that. We are asking to create a dictionary according to the tf.data, but still the output will be integer. Otherwise, we cannot convert the in the text generation, for example, we cannot convert the from the output to the string. Okay.
We have to find a combination, right?
Yes. So from the audience, if anybody has a brilliant solution, please share your code. Please share your ideas into the comments below. We are going to use it maybe in the next meeting. Thank you.
So now we need to split the data into train and test sets. We have features, the text column, as you can see, and we have a category ID column as targets. So we can split the data.
Why we are splitting data before preprocessing?
Because we are going to pre-process the training data. Because you explained it to me, if you are pre-process the test data, it will be wrong because test data, it should be unseenable. Okay, we shouldn't see the test data. We shouldn't touch it. So yes. That's why.
Okay. So as a concept, there is a concept data leak.
Yes.
Okay. So the data leak means that you are using some information when you try to build your model, which you shouldn't access it. For example, as we know that we are evaluating the model success by using the test data. If you use your test data information in building your model, it's a cheat. So it's called, if you do on purpose, unintentionally, it's a data leak. It's an error. But if you do it purposely, it is a cheat. Yeah. So when you are gonna try to create a preprocessing rule, you first begin with the splitting data in training, test, or training validation test. Then you can use training validation or training data to put your preprocessing rules, apply them onto these, and then to the test. But if you check the test data as well and try to create some rules, preprocessing rules, by looking at the test data, that is cheat or data leak. So it's not good. In real life, your testing accuracy will be very high, but when you deploy it to a real life platform, you will astonish that it will be very low or lower than what you have seen on your computer test environment. So basically, keep in mind that for everyone, if you are gonna preprocess the data, if you need to analyze for that data, first split the data and then work on only training part. Put all the rules, understand, create your rules according to training data, but don't look into the test data. Okay. Yes. It will be surprise. So keep it as a surprise and do not try to modify your model or preprocessing, including preprocessing layer, according to the test data.
Yes.
Okay. Assume that the only information you can access is in the training data, not in the test data. Is it clear for you, Cansen?
It is clear.
Okay.
That's why I split the data before the preprocessing the training data. So now I can remove the read more part.
But by the way, did you shuffle the data?
No, not yet, but I will shuffle.
Because remember that in the raw data set, they are ordered according to the topic.
Yes, category. Yes, but I didn't do it before this. So after the preprocessing, I will shuffle the data, but I wrote a don't read more function to do this. So, and I'm going to try to remove this part. And if we check the last of the reviews, as you can see, there is no read more, but also there are some. Yes, and also I lost some words also because the devamını is yes.
Okay, that's what I am trying to explain. We are using a string function split. Go to your code about just yes here. Okay, I think still you are using split function. You see that? Please highlight it with your mouse. Highlight with your mouse. Right. Here in that split function, as I explained, it's just a basic function. It's not a text level preprocessing tokenization function. It's not. So do not use it. Why do you use here a preprocessing? We have talked about that we are going to use text vectorization. Why didn't you use text vectorization layer, custom updates? Why you use here the Python code?
Yes.
If you use this Python code here, it will be out of the model. It means that your model cannot use this function, right? So when in the test data, when there is a devamını read more, you cannot remove it, right?
Yes.
So please do not use for two reasons. First, split is not a good for tokenization, as we are looking for in the text processing. Second, do not use Python functions to preprocess the data. You need to use all your preprocessing embedded in the model. The easiest way, use the text vectorization layer for that reason. Do you agree?
Yes.
Do you see your mistake here?
Yes, I have seen, because I lost some words in here.
Yeah. And by the way, you cannot apply the same logic to the test data because it's out of the model. You are just providing the test data to the model. Don't forget. So don't do this. Okay, it's a good or I don't know, bad example. So it is the way we are not always saying that do this. Now we are saying this, don't do this. Okay, Cansen, don't do this, okay? Don't do this. I will explain in a moment how to do in your code. I will explain in 10 minutes.
Okay, so we can check the feature values. These are the train features, our reviews actually, and we have train targets as an integer, as you can see. These are our values, and now we are going to create prepared our train feature values and also train target values, and we are going to use the element spec to see the type of the elements in here for the everything in the that train text DS row. Be prepared for this. This is a train data set. It's a text part and it's a row. And we have also, for the train, we have category DS row. And also we prepared this one. And after that, we need to specify some values like the vocabulary size and max length, maximum length actually. So max sequence of maximum sequence size, and these are the we are going to consider only top 90K words.
But as we explained, that is not the best way to create your dictionary according to the frequency of the words. We already discussed.
Yeah. Yes.
And the max length is the maximum token size in the review. In that case, in our case, it is the number of words in the.
Yes. And again, I have one mistake in here too, because these parts to trying the digits and numbers and punctuations, it should be in the text vectorization layer.
Okay, let's come to the custom standardization.
Okay, I will fix it.
Okay, now explain what we are doing in that function.
Okay, custom standardization, actually, this is a function that we wrote.
It's a Python function.
Yes, but we don't have to write it actually. If you are using a default one in the vectorization, text vectorization, it will be remove the punctuations and it's going to be a lowercase for all your letters. But we have some special cases also in here. Sometimes we have some HTML text and something like that. So that's why we wrote our own function for the standardization.
Let's stop here. It's getting a little bit confused. First of all, we try to do everything, every possible preprocessing in one place. So we create the function, right? So, but you didn't do this in that way. If you go up 1, 2 cells up, go up. For example, here, you try to do what? Remove the punctuations, right? Yes. Okay. Just copy this line. Just copy this line. And come back to the custom. And just here at the last line, you see that we already have the removing the punctuations. Do you notice that?
Yes.
We have already. Now let's select the other thing from your code above. Go to the above. No, we have already done, so you don't need to do this.
I have a problems with the numbers actually.
Okay, let's get the number, but we also remove numbers, no? Okay, now let's see how can we do this. So we are gonna use, in that Python code, we are gonna use always TensorFlow functions. I will explain it why. So here we are gonna get the pipeline, the last item from above. No, you need to copy tf strings regex replace from the above or below, it doesn't matter. Copy is a function call. Okay, put there. Now we have to provide the input, the last updated input here, stripped HTML, copy the name, and paste it as the first argument to this function. Delete the lambda, delete. And comma, paste this, comma, comma. Now we have to provide the regular expression. You remove this and remove this parentheses. No, okay, only the parentheses. Okay, then You provide, this is the rule, and then what to replace with? Nothing, and then remove the rest. No, there is no, remove. You don't need to add. It is already there. You see that single quotation mark, single quotation mark. It is there. So you don't need to put your quotation marks. Remove. Only one pass. Remove. To the left. Yes, remove. Now, you have one excessive parenthesis. No, you have to remove.
All of them.
You have to remove the extra parenthesis. It should be one parenthesis.
Okay.
Okay, and then there will be no space. You put your space. No. You are just confusing what you are doing. Just look at it that the F in the commas.
It should be like this.
Yes, this is the first parameter, comma. Don't do anything for that. Comma, what to replace? You now put a space in between. No, we don't need space. So delete the space, put the single quotation mark next to each other. Single quotation, single quotation. Okay, do you understand what you've done? Yes. You get the strip HTML from above. You remove all the numbers with nothing.
Okay, I will fix it.
You got it?
Yes, I got it.
Okay, so this is the way how you do it. So go up to the devamını oku, read more.
Also, I should
here
apply this function in there.
So you are gonna do basically this. Go to the down to the preprocessing layer.
Okay, it should be also in the custom standards.
So, for example, just copy the last line here, train features. Copy all of them. Copy. Control J and insert. Okay. Now, tf strings regex replace will be the same command, but the input will be train feature. Okay. What we are looking for, devamını oku. Since it is after the
dot.
Lowercase, but not the punctuation. So it should be after the punctuation so that dot devamını will not be confusing. Okay?
Yes,
I will show you how can you do this. But just write there, devamını oku.
Okay. I'm taking notes actually. I'm going to fix that.
Okay, but let's do for the, you don't need to put the uppercase D. Remember, we have already lowercase everything at the first line. Okay, so after oku, you need to remove these symbols until the single quotation mark. Seal. Let's delete, erase. Okay, now with what? With nothing. And the new name, let me put there onto the left side. In the side, yes. Put there, for example, no. We need to change the name of what we've done. So onto the left, put a new variable, no repeat, for example. No repeat. Okay. Now, please copy the last line in the return. No. We are gonna do something different. Just copy this last line. No. Return. Just the command tf string, not the return. Yes, all of them. Copy all of them. Control C or Control K. Okay, and go before the no repeat and paste it before no repeat. Paste it.
Okay, first of all, I'm going to remove the punctuations and then I'm going to remove the repeat.
So provide the train feature as the input for that one. Train features, copy paste train feature as the input. Okay, give these output as no punctuation. Okay, now use the no punctuation as the input for this, and now return no repeat.
Okay.
Delete everything here.
I'm going to delete all of them.
Yes. Delete everything. Delete everything. Yes, only, but do not put parentheses. It is something different. Okay. Now, you understand how we create the preprocessing pipeline. So in that pipeline, we basically use TensorFlow strings class, regular expression replace basically to replace this. But there are still something you forgot or you haven't done to convert the Turkish letters to English letters.
Yes.
Right? You forgot. How can you do this if you understand this? With ease. For example, how can you change the ç in Turkish to C?
I need to write a regex for the each Turkish letters like the ç.
There are 6 of them in lowercase because we already lowered. And
I'm going to change them with the English versions.
Yes. But your function does not work, I am sure. And you have not defined, tested it, verified it, because there are missing a lot of parameters. For example, in the lowercase, you have to provide the encoder UTF-8. Otherwise, the Turkish big letters, upper letters cannot be lower.
Okay.
Okay. Now, what you have done, please go to the next line and create a code line. Code line, not code. Yes, create a code line after that. An if cell. Okay. Now, put here like that. Output, assignment.
Is that the name?
Equal assignment. No. The assignment side, equal. Okay. Custom standardization. No. Assignment is the equal in C++, C. Okay.
No, okay.
Custom standardization, the function name. Okay. In parentheses, in single quotation or double quotation mark. In pijamalı, P is gray in uppercase. Pijamalı, ilginç, E is uppercase, E uppercase. Otobüs, çıkıp,
maybe I can add some punctuation.
Yes. Öldü, gözleri. So these are some, right, Turkish alphabet letters. And so you and go to the next line and print output, for example. Go to do it, please. Go to next line. No. I mean in the next line, in the same place. Next line. And print output. So you have to do this and see that if the output, print in parentheses output, is as you expected.
Yes, I can check all of them.
And you will see that now, however you write it, it will not work. It will not convert because you forget to handle the UTF-8 decode in Turkish. Otherwise, it will not work. It will not the TF strings. But the point is that if you go to the upper cell, here we create a Python function using only TensorFlow operations, TF operations, TF functions, which is strings. We are handling this. But if you are using, for example, image processing, you have to use TF, TensorFlow's image preprocessing functions. Do not use Python functions in here. So in one place, here, what you see that we create a pipeline. We are taking the raw data, preprocessing by user TensorFlow functions, one another the other, until all the preprocess done in one function. Is it clear for you?
Yes.
I think it's clear for everyone. right?
Yes.
So, but don't forget, we are using only TensorFlow. So if you are interested in data pipeline, I have a special tutorial series for TensorFlow Data Pipeline. So I will put the link in the video description. You can use it, but basic I am talking. If you are using this pipeline, put everything into one Python function, but using only TensorFlow functions, tf. something. Now, we are ready to use this function in the model layer. Let's go there.
Okay, I got it. Thank you. So this is our custom standardization. So it means that when we adapt this layer to our data, it's going to apply to all these reviews, all these texts. So we are using custom standardization, and our output mode is int. Still, it is int, but it can be also tf.df. But I need to search it, as I said before. And we are using a maximum length. So then this is a layer you already.
Can I explain something? So text vectorization is a layer, just like a dense layer, just like a LSTM layer. Okay, it's just a layer already prepared for you by Keras. So you can use the Keras layers, everybody knows. It's just the Keras layer as an input layer. Okay, text vectorization. It takes some arguments. Here you see that first argument, how to handle the given input. So this text vectorization layer must be after the input layer. So the first layer or the second layer in the model, it must be. Why? Because it will receive the input and apply something on it, preprocessing. So our preprocessing is, we have done in the custom standardization function, Python function. So we are basically saying that when you receive input as a layer, apply this function onto that. Is that clear?
Yes.
Okay, this is the place. The second one, argument, please highlight the second argument, maximum tokens. So basically, this is the size of the dictionary. Because in the corpus, there, I checked last time, 1 million different words, but including the syntax errors, Turkish letters, blah, blah. But 1 million tokens, roughly. So you cannot create a dictionary and then make a classification on that, prediction on that 1 million items. So the probability will be very, very low number, so you cannot differentiate, and you cannot train, you cannot converge. So you need to eliminate some of the tokens, as we discussed in the last hour. It could be based on the number of frequency or the tf.df. For the moment, we are talking about the number of frequency. So we are saying that max token is vocabulary size -1. Why? We already decided that vocabulary size is 90K.
Yes.
We said that 90,000 unique words. Select the most frequent ones among the possible 1 million tokens. All right. So this max tokens is that because text vectorization layer, after working on training data, will learn and produce two outputs. The first output is a dictionary. So what is a dictionary? Or vocabulary. Cansen, what is a vocabulary?
So these are the frequencies of the
vocabulary. What is the vocabulary?
It's a vector.
It's a dictionary.
Yes.
The key is the string, and the value is one index, or the other way. So we are gonna provide indices. So what kind of indices we are asking for? Integer. So the output mode integer means that build up a dictionary, at most vocabulary size dictionary. For each string token, please create an index corresponding this token as an integer number, right? And the output sequence length means that
50.
You are gonna trim longer reviews inputs with this number. Now max then is 50.
50. Yes, 50.
So after preprocessing the text, this layer will produce you some integer numbers. How many? 50 integer. Why? Because max 10 is 50. Why integer numbers? Because we request the output mode integer. What about these integer numbers? Each integer number will correspond to a text token, a word, in the dictionary. Am I clear?
Yes, really, very clear.
So I said that this text vectorization has two outputs. One is dictionary. What about the second one? What is the second function? First output is dictionary, indices, and the token, string token. The second one?
The second one, are you asking to get the vocabulary back from the integer value?
No.
Okay.
No. The other one is when you provide a text, it can convert to integers.
Yes.
Yes. So in the first, we need to train this layer to create its dictionary. The first output is dictionary, but then we are going to use this layer to create the integer array for the given sentence, for example, for the given review. So now you are adapt. Could you please click the adapt?
Yes, okay. Adapt function.
Here, this is the adapt actually means that the model fits. Okay, actually, it means that this layer will work on the trained data. It will try to preprocess the text as we requested, create the dictionary, find the indices. That's all.
Yes.
But it will not convert anything to integer. It will just learn how to do. Am I clear?
Yes, you're clear. And then after the fit, adapt function, we can use this layer when we need it. So
here you have the get vocabulary. So you see that you get the first output from that after the adapt, right?
Yes.
Let's continue.
It will learn. And also we have a get vocabulary function. So to get the words back from the indices, because when we need to see the text type of these integer types, so we can call this get vocabulary function to reach the text again. For example, we are going to see the examples in here.
So here again, the first 10 entries according to the frequency.
Yes, again, frequency. The TF-IDF is just for the analysis. We haven't used TF-IDF in here.
We haven't integrated into.
Yes.
We need to think. Yes, okay.
And as you can see, we are representing the words with the integer numbers, integer values. And for example, we have a raw data in here. This is our review, as you can see. And when we tokenize and transform with using the vectorize layer, we are going to take this result like this.
So this is the array of integers. The size of it show the shape 150. It means that there is one statement and it has 50 tokens. So go to the code, please. Here in the code, right? So we have the trained data. X is the one statement, show the X there. On that same line, no, upper. Yes, here X is one sample from the trained data. It's a one review, right? And we put in the next line, we show it is in string format, in string. Then we apply the vectorized layer, show it, vectorized layer on it, so that the second output of the vectorized layer is converting a string, a sentence, a review, converts it to a integer array. Show in the below.
So this is our string mode,
yes,
as you can see, and this is our integer array after the vectorized layer applied.
In the code, it is X, the string is X, and vectorized layer X is the array of integers. And please notice that it is 150. 50 is the maximum size. So it trims. If it's longer than, it will trim at the 50 position. If it is shorter, it will look at the 0. 0 means nothing. So it will padding at the end of the review, if it is less than 50 words, with zeros.
Yes.
Automatic padding is there.
It's looking at the frequency, of course, in here. So we are going to squeeze this vectorized layer text for all of them. And then we are going to prepare our train text. Yes, this is not a raw text anymore because we have applied preprocess on this train text data. And this is again inspect the type of each element component. And then we prepared our train text DS. This is the vectorized mode also, and train category DS row. And this was the contains the category ID, as you can remember. Now we can zip all these informations and we can create our train data set as a result.
Okay.
So let's check some examples again. As you can see, in the train DS dataset, we have X and Y. So this is actually features and this is the target for us. So as you can see, this is our X. This is integer array representation of our one review. And what is the target? For example, for this review, target will be this one, 22.
This is the topic number.
Yes, it's a topic number. And if you want to check it in the string way, in a string type, in text, it's, as you can see, there's a string type. And what is our category ID as a category name? It's going to be mobilia and F text.
By using the ID2 category dictionary.
Yes.
We
created this dictionary to take the category name from the category ID. And also we have another example here. Again, from the train dataset, we prepared the train dataset. We have an X as an integer array and we have a Y, its features and target. For example, the category ID for this one is 15. And in the text mode, in the string mode, the 15 category ID will be the internet. And there is another example. Okay, this is our train size at the end of it. And we can look at the train DS values in here, but...
No, it is here, it is showing that it is already shuffled train set. Remember, if you go to the above, when you do train sets, so we already requested the shuffle when you split the test and train.
Yes.
When you split test and train, automatically shuffle is true. So
that's why it's not ordered anymore.
Yes. So you see that in the batch, in the mini batch, the topic numbers are different. So we are ensured that the topics are mixed, shuffled in the batches.
Yes.
Otherwise, do it again, be careful again and do it by yourself in the data pipeline. Maybe I will show in the next line. If you go to the next line, go to next. Here, we can shuffle by ourselves if there is a problem by using the buffer size as the train size. So now we can ensure again that, but as I showed in the previous cell, it's already shuffled, but you can shuffle again.
Yes. So it was starting from the 0 and goes to the 31, but as you can see in the first 10 example, it's mixed. And again, you already explained that we shuffled the data, and it's again, the first 10 example is different now because we shuffled again. So now we can prepare the test data. It's going to be the similar way, but we are not using the vectorized layer in here.
No, we are using. If you go up and stop here.
Yes.
Here, don't stop, just somewhere stop. Okay, here in the bottom, prepare language model inputs label. Click over there. So this is the function embedding the vectorization layer, remember?
It's in here.
Here, click the, yes, vectorization layer here. So it is a auxiliary function, help us to vectorize it because we already trained this vectorization layer on trained data.
Yes.
We already train it, adapt it. Now we can use it on the test data. Okay.
Yes.
Don't forget.
I'm
We are using it.
confused. So okay, I'm starting from the beginning. So while preparing the test data, we have already some pre-processing processes for the training data. Now we need to prepare our test data with the same process actually.
And this processing layer is trained on only on training data, not test, but we apply to the training data. What I am trying to say that there are some unknown words, for example, right? We exchange some words with unknowns in training data because they are less frequent than what we decided. And these words will be unknown in the test data. Or there is some word that never happens in the training data will be unknown words still, if it is in the test data. So I think it makes sense, right?
Yes.
So we learn from trained data set how to convert from tokens to integers. After learning, we apply to trained data and test data.
And again, after this part, we finalize the test data set.
We create a tuple, XY tuple here.
And again, it's going to be the same thing. In our test data set, we have X and Y, I mean the feature and target. The feature is going to be a review again, the integer array representation of review, and Y is going to be the category ID. It's like this, something like the training. And we can check the test size. Test size, as you can see in here. And for the finalized data pipeline, we are using batch, cache, and prefetch.
So if anybody would like to learn the details of these are very important concepts. If you are dealing with large amount of data as we did here, right? 400K reviews. So you need to understand how to use this TensorFlow Data Pipeline. I have a special tutorial series. There are 4 or 5 videos, tutorials and with codes. Please check the video description to access these tutorials to understand the details of it. Okay.
Yes. And we batched our data, so we can check the some examples again. From the train data, we have X and Y, but for this batch, you can see that
Why we see there 64, Cansen? Why in the shape?
Our batch number 64.
Yes, this is the batch size.
Batch size.
Batch size. So in the batch size, we have 64 samples, and each sample in the X are 50 integer, right? Integers, yes. And as a X in the Y section, we have 64 scalar values. So if it is scalar value, it means that we cannot put 1. Because 1 is not scalar value. 1 means that there is a vector with 1 integer, but we just an integer, so it's a scalar value. We just use the Python or the TensorFlow just use the comma. Okay.
Because this is Y and it's going to be a 1 value, the category ID.
A scalar value.
Yes. And again, this is our X with the integer representation. We can see the shape is that. And also we have a Y. It's going to be, you have already explained it.
At the end, you see that numpy is 4. Do you see? Go to that. Yeah? So it is a scalar value 4. The class 4th or 5th class actually. Yes.
Also, thanks to our dictionaries, we can always check the what is this category ID in the category name. And also we can check the our auxiliary helpful function. We can check the string type of the this integer array.
So you see that the first token is unknown. You see that in the
Yes,
example.
1.
In the text, it is unknown. Why it is unknown? Because the dictionary does not hold any string with that word, and it cannot convert to any integer indices. Then it converts to one integer, so that it means that one means that unknown, any word, which does not exist in the dictionary. Vocabulary.
So that was the data analysis and data preprocessing.
Okay, thank you. So far we have discussed our problem, multi-class text categorization. Then we talk about how to analyze the data, and then how to preprocess the data by using text vectorization layer in Keras preprocessing layers. We will continue in part B to build a GPT-3 like model, custom model, and maybe with Bert, how to classify this data and how to analyze the success of the model. Do you want to add something, Cansen? Otherwise,
no, thank you. And also, I want to thank you for the contributions. I'm going to fix my notebook with these new suggestions. Thank you.
All right. So for the moment, we will stop for the part A, and we are going to continue with part B. If you are interested in, please subscribe to the channel and continue with part B. See you in the part B. Bye-bye.
Thank you.
See you, Cansen, in part B.
Okay.
Bye-bye.
Bye.